Good evening, man. I'm a bit better now. We thank God. Yes, ma'am. Is Sarah around? Can we have our class now? Good evening, Sarah. How are you? Okay, I'm ready. You can join me online. It's better now. Yeah. Okay. Okay, if you're here with me, you let me know so that we can begin the class. Sarah, are you online now? Sarah, are you here?
1.6. We are asked to evaluate the following, leaving your answers in standard form. Exercise 1.6 will help you understand better the basic operations of multiplications. So, 1, we are asked to multiply 5 times 2.
Sarah, are you here? If you are here, you let me know. We are about starting today's class. Sarah, are you with me? You're welcome to today's class. Okay. Okay, Sarah, welcome to today's class. Today's class will be a continuation of our previous classes on laws of indices. And in our previous classes, we have looked at 2 of the laws of indices. I've probably introduced indices to you, and we're now looking at the laws of indices. The first law we looked at is said to be the addition law of indices, where we said when you multiply 2 indices together, that you add their powers. That when you add their powers is the same as when you multiply them together. And that we did so many examples on them. We also looked at the second law of indices, which we say is the indices law of subtraction, where we said when you are dividing 2 indices of same base, that it is equivalent to you subtracting their powers. And we equally solved so many exercises on that. In today's class, we shall take the third law, which is said to be the indices law of multiplication. And I'm going to show you what the law says. The indices law of multiplication is same as what I have on the board. The example 1 that says we should evaluate when you have an expression like this, that you should evaluate bracket y squared or cubed. We refer to the process of solving this as indices law of multiplication. Ordinarily, I told you that when something is being cubed, it means you are multiplying that thing by itself 3 times. So in essence, this is equal to y squared times y squared times y squared. That is what this expression means. Y squared or cubed means y squared times y squared times y squared. And you can best solve this using the laws of indices, which is the first law. But even if you don't want to do this, you can still break this down to be y squared means y times y. So this is y times y times another y times y to multiply by y times y. And this can be said to be y raised to the power of 1, 2, 3, 4, 5, 6, which is y raised to the power of 6. And if you look at it, you agree with me that the answer we got is equivalent to when you multiply 2 and 3, which is y raised to the power 6. So I said the power in the final answer is equal to the product of the power of y squared and the power outside the bracket, so that y squared or cubed can be said to be equal to y raised to the power of 2 times 3, which is equal to y raised to the power of 6. Let's take another example. Example 2 says we should evaluate x raised to the power of 4 or cubed. This is also said to be x raised to the power of 4 multiplying itself 3 times, which is x raised to the power of 4 times x raised to the power of 4 times x raised to the power of 4. So when you multiply this is going to give you x raised to the power of 4 is going to be x times x times x times x times another x raised to the power of 4, which is x times x times x times x times another x raised to the power of 4, which is x times x times x times x. So this can be said to be equal to x raised to the power, this is 4 plus 4 plus 4, which is x raised to the power 12. Same thing as we did in the first example. If you look at it, you will agree with me that x raised to the power, the answer we got, is also same to me when you multiply the powers of x outside and inside, so that this becomes x raised to the power of 4 times 3, which is the same thing as x raised to the power 12. So I said the power in the final answer is equal to the product of the power of x raised to the power 4 and the power outside the bracket. So x raised to the power 4 all cubed is said to be equal to x raised to the power 4 times 3, which is equal to x raised to the power 12. So in general, having looked at these two examples, if you should take another example, you equally arrive at the same thing. You discover that the answer you get will be equal to when you multiply the power of x and the power outside the bracket. So in general, we say that when you have an indices expressed as a raised to the power of m or raised to the power of n, it will be equal to a raised to the power of m times n, which is equal to a raised to the power of mn. Definitely, when you multiply m times n, you get mn. So this is called the indices law of multiplication. And the indices law of multiplication, one more time, says when you have an expression a raised to the power of m or raised to the power of n, it is equal to a raised to the power of am times n, which is a raised to the power of mn. So let's use what we have learned in the indices law of multiplication in solving more exercises. So let's look at exercise 1.9. But before then, let me get feedback from you. Do you understand all I have said on indices law of multiplication? Is it clear to you, Sarah? Sarah, are you with me? Let me get a response from you from the comment section. Okay. So let's go ahead with exercise 1.9. Exercise 1.9, we are asked to evaluate the following, leaving our answers in indices form. The first is 3 squared all raised to the power of 4, 2, 7 raised to the power of 4 or cubed, 3, 9 cubed all raised to the power of 5, and 4, 12 cubed all squared. So we are going to apply the indices law of multiplication in solving this. So let's solve. Example 2, I'm going to solve example 1 at the end. Example 2, this can simply be expressed as, with our knowledge of indices law of multiplication, this can be said to be 7 raised to the power of 4 times 3, which is equal to 7 raised to the power of 12. Number 3, 9 cubed or raised to the power of 5 can be simplified as 9 raised to the power of 3 times 5, which is equal to 9 raised to the power of 15. The question says we should leave our answer in indices form. So you are to leave it in this form. Otherwise, if you are to leave it in ordinary form, you have to multiply 7 times 7 times 7 in 12 places. Number 4, this can be said to be equal to 12 raised to the power of 3 times 2, which is equal to 12 raised to the power of 6. And number 1, this can be said to be 3 raised to the power of 2 times 4, which is equal to 3 raised to the power 8. Kindly like my video as you watch, while I recommend that you subscribe to my channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. You are also advised to share the link with your friends and families so that they can also benefit from our daily classes. We shall now take more exercises, a little bit complicated than this. In this next exercise, you are going to be having a constant term, and it's going to be in algebraic form, where you have a coefficient and an indices. So let's look at this. Exercise 1.9b. But before then, Sarah, do you understand all I solved on exercise 1.9? Do you understand the solution, how I got them? I believe these are simple for you to solve. Sarah, do you understand? Sarah, do you understand? Exercise 1.9. Okay. If you do, let's look at exercise 1.9b. Just like I said, we are going to upgrade it from the normal indices that I have just solved. Let's keep making it look complex to see how it can be solved. Now, we are asked to evaluate the following, leaving our answers in indices form as same as what we did in the first example. This now can be also stated to be, now when you have this 2x squared or cubed, this cube will affect everything in the bracket. That's what it means. Okay, that you have to cube 2x squared. Ordinarily, this can be expressed as 2x squared times 2x squared. And when you multiply 2x squared by itself, this is going to, you're going to multiply out the 2's, which is 2 times 2, as well as x squared times x squared. And if you apply the law of indices, this is equal to 2 squared can be said to be 2 raised to the power of 2 times x raised to the power of 2 plus 2, which is 4, right? So this is equal to 4x raised to the power of 4. Now, what? Okay, this is times 2x squared, okay? Because it is cubed. So I'm supposed to multiply it 3 times, okay? So that this can also be said to be 2 times 2, and you have times x squared, right? So that this gives you 2 raised to the power of 3 times x raised to the power of 6, okay? So this is, and 2 raised to the power of 3 is said to be 8. So this is going to give us 8. So our answer becomes 8x raised to the power of 6. Now, you can apply the law of the indices law of multiplication in solving this by cubing every term you have in that bracket, which can be said to be equal to 2 cubed times x raised to the power of 2 times 3. So you multiply every power of every term in that bracket, or how will I put it, by every letter or number or digit in that bracket. That is why I have to cube this. This is 2 raised to the power of 1, which gives me 2 raised to the power of 1 times 3, which is 3. And this is x raised to the power of 2, which is x raised to the power of 2 times 3, which is equal to 2 raised to the power of 3, x raised to the power of 6. And since we are asked to leave it in indices form, this is what you get. Otherwise, you leave it in ordinary form, which is this. Question 2 says 5y cubed all raised to the power of 4. Same thing I'm going to do. I'm going to multiply every power in that bracket by 4. When you have a constant term like this, note that this is 5 raised to the power of 1. The power there is 1. So this is equal to 5 raised to the power of 1 times 4, y raised to the power of 3 times 4. You can call it times y raised to the power of 3 times 4. So that this becomes 5 raised to the power of 4, y raised to the power of 12. So this is what you will get. 3, this is equal to 3 raised to the power of 5 all raised to the power of x, can be said to be 3 raised to the power of 5 times x, which is equal to 3 raised to the power of 5x. Question 4, p raised to the power of 4 into all raised to the power of 5. This is equal to p raised to the power of 4 times 5, which is equal to p raised to the power of 4 times 5 is said to be 20. And question 5, 17 raised to the power of 3 or raised to the power of 4. This can be expressed as or simplified as 17 raised to the power of 3 times 4, which is equal to 17 raised to the power of 12. Just like I said, the question warrants us to leave our answers in index form. Question 6, this is equal to 11 raised to the power of x times y, which is equal to 11 raised to the power of xy. When you multiply x by y, gives you xy. Number 7, this is equal to 5 to power 2 times 3, which is equal to 5 to power 2 times 3 is said to be 6. Question 8. At this point, I want you to solve from question number 8 down to question number 17. Let me see if you are actually following the class. So what will you get as your answer for question 8? Use the comment section to give me your answer. Trust you are welcome to this class. Kindly introduce yourself. Let me know where you are chatting from. Thank you for liking. I see you. So kindly solve question number 8 and let me see your answer. Kindly like my videos as you watch, while I recommend that you subscribe to my channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can use the comment section to interact with me on areas that are still difficult for you to understand. You can also share the link with your friends and families so that they can also benefit from our classes. Sarah said question number 8 is 2 to power 9. 2 to power 9. Okay, that's beautiful. What is the answer to question number 9? What's the answer to question number 9, please? Question number 9, she said it is m to power of 36. Okay. Question 10. Question 10. What was the answer to question 10? Question 10, she said is 2 times x to the power of 42. Sarah? You're wrong. You made a little mistake. So look at it very well. Remember I said you also raise the power of 2. You also multiply the power of 2 by the power that is outside. So the power of 2 is 1. So multiply by 7. Sarah, are you with me? Look at your answer to question number 10 again. It's not complete. I'm not saying it's not correct, but it's not complete. Because it is partially okay and partially it's not okay. Remember I said you multiply the powers of every figure or letter in that bracket. Okay, Sarah, in question number 10, this is what I expect you to do. Question 10, this will be equal to 2 raised to the power of 1 times 7 times x raised to the power of 6 times 7. You forgot to multiply this and 2 raised to the power of 1 by 7. So this ought to have given you 2 raised to the power of 7 times x raised to the power of 42. But you omitted this. That is why I say your answer is wrong. Okay? So don't forget. In question 11, now look at question 11. This power only affects what is in the bracket. So this power will not affect 5. So that this gives you 5 times x raised to the power of 4 times 3, which is equal to 5 raised to the power of 12. Unlike in the first example, where I said the 7 also affects 2. Why? Because 2 is within that enclosed bracket. But in question 11, 5 is outside of the bracket. So 5 will not be cubed. I hope you got that. So let me see you solve number 12. 12, 13, and 14. Sarah, do you understand now? Sarah, is it clear to you? Sarah, are you with me? Sarah, I'm not getting responses from you again. Do you understand what I said concerning the correction in question 10? Okay, so kindly solve that of 12, 13, and 14. Thank you for joining my class. If you are here with me, kindly introduce yourself. Let me know where you are watching this live stream from. You are watching the live stream from Nigeria. Let me know where you are streaming us from. Sarah, are you still with me? Sarah, are you with me? Let me get solution to question number 12, 13, and 14. Okay, what's the problem? Have you been able to solve the problem now? What you refer to as the problem, have you been able to solve it? Sarah, you can call me and let's talk about your problem. Okay. I now understand your problem. All right, so go ahead and solve. It's network issue. Sarah, I'm still waiting for question number 12, 13, and 14. Okay. Number 12, we said is 2 to the power of 3 times b to the power of 12 times c to the power of 21. That's correct. You're not getting them. Number 13. What about 13? I'm waiting for question 13. Answer to 13, 14. 13 to the power of 2 times m to the power of 8 times n to the power of 12. Yes, correct. Okay. Okay, let me give you another for question 13. Question 14. Question 14, let it be okay, take this as your question 14. So let's solve this. If you are just joined us online, we are solving mathematics on laws of indices, and we are having some exercises on the board to solve. Kindly solve and let me have your answers using the comment section. You can as well introduce yourself, let me know where you are streaming us live from. And please don't forget to like the videos as you watch. Let me know what you feel about this class. Thank you, Trucks, for the likes. Trucks, how are you doing? Do you speak English? Trucks, where are you streaming from? Hey man, I can't pronounce that name. Is it ABHATN1? I'm fine, and you? Good to have you online. Where are you watching this stream from? Okay, Aditya, you are from India. Wow, nice having you. I'm from Nigeria, West Africa. Yes, we have been having this online classes for a while, and is to help students to upgrade themselves in math, physics, and chemistry. So for today, we are looking at JSS2 mathematics, that's junior secondary mathematics, and we are looking at laws of indices. Thank you too. Love more to India. I have so many great teachers from India. I've read so many of your books by Gupta and so many authors. They are great mathematicians. I think most of the textbooks we have are written by Indians. Yes, I love them. Yes, I do prepare students for exams. Thank you so much. Aditya, I appreciate you. Okay, JEE Mains and JEE Advanced. Oh, that's nice. In Nigeria, we have the 933. Is it 933? Okay. 633 system, but it has been upgraded to 993. But I think we are still operating on the 633 system. But at different intervals, you need to take your exams. For those in the junior, you have to take it at GSS3 upon completion of your GSS3 exams, where you have your best certificate, and as well as when you are done with your secondary, you now sit for your West Africa examination exams, which is your WAEC, NECO, and to take you to the higher level. Nice having you, Atsa. Nice having you online. I appreciate you. Please kindly drop your WhatsApp number so that I can give you a call, and we'll have to talk more. Yes. Sarah, you have given me solution to question number 14. You say 2 to the power 3 times b to the power 12 times c to the power 21. I will do that. Aditya, I will do that. I will do that. I love difficult questions, okay? So that I can give students the solution and the tricks in solving them. We will do that. Thirty over 100 gives 95% plus. Wow, that's nice. That's nice. Percentile. Wow. Are you serious? Are you serious? 30 to 100 gives 95 plus percentile. Wow. I will. Sarah, question number 15 should not confuse you. You have two brackets, okay? So all you need to do is z to the power 3. You have to simplify them simultaneously. Z to the power 3, this cube only affects z, okay? So cube z, and then multiply that by what you have in the bracket. If it is still confusing to you, this is what you will get, Sarah. This will be equal to z, this is 0 to the power of 1 or cube, giving us z cube times x plus 2y. Okay? Since we are required to give our answers in index form, I think this is what you will do. But to simplify this further, you can then use the term outside of the bracket to multiply every term in the bracket, so that this gives you x z cube plus 2yz cube. Okay, all I did was to use z cube to multiply every term in a bracket. And when you do that, you will get this. Now, in multiplying algebra, you need to arrange them in alphabetical order. That is why when you multiply x cubed times x, it gave me x z cubed. X comes before z in alphabetical order, and as well as y. Now, when you have the mixture of numbers and letters, the numbers should come before the letters because the numbers are standing in as the coefficients of that letter. Okay? So this is what you will get. I hope you understand now. So let me see you solve question 16 and 17. Adia, you say I should search for JEE Advanced 2023 exams. I will do that. Safia, you're welcome. Safia, good to have you on our live stream. Where are you watching us from? From Dubai. That's nice. Safia, are you a student, a teacher, or a parent? That's nice. Good to have you. Okay, you say you've met African people and they are great. Yes. In every, that's what I tell people, everywhere you find yourself, you have the good, the bad, and the ugly. In as much as you have met the good ones, we also have the ugly ones, and we also have the bad ones. I also met great Indians, and they are just good. I will tell you the truth. Thank you, Sophia. So, Sophia, are you enjoying our classes? We are having a class on laws of indices. Please don't forget to subscribe to my channel, as well as to like my videos as you watch. I have a lot of them already. You can watch the live streams. You can also watch the videos I have made. I have over 100 videos on mathematics, physics, further mathematics, which you can enjoy from. Adia, I don't know Modi. Wow, Sophia, that's nice. Thank you for subscribing. And your best friend is from Nigeria. That's nice. What's his or her name? Okay. Adia, you said Modi has been to Nigeria. Wow, that's nice. Safia, her name is Aisha. That's nice. Oh, that's the Prime Minister of India? I don't know. But that's nice. That's nice. Nigeria is a great place, I promise you. And you know the funniest part of me? I don't want to leave Nigeria. I love my country. But I may likely travel out to visit one or two places to gain more knowledge and add to what I have, bring it to Africa, and develop our country. The same way you are doing in your country, and so many others. Nana, you are from Morocco. Nana, you are welcome. Thanks and good to have you in our class. Nana, are you a student, a teacher, or a parent? Oh, Sophia, we love to have you in Nigeria. Nigeria is a great place, the giant of Africa. Nana, have you subscribed to my channel? Oh, Nana is a student. Nana, what level are you? Are you in the primary, senior, or junior secondary? Okay. Idiot. I will do that, but let that be for another class. Oh, Nana is studying engineering. That's nice. So mathematics should be one of your requirements. But we may call it engineering mathematics, also known as further mathematics. You should be studying things like calculus, matrices, and all whatnot, vectors and the rest. Adia, bye. But please don't forget to share my videos, okay? I'll need to have more students online. Thank you so much for being part of today's class. I really appreciate your time. Okay, Nana, what I teach in my channel is maths, physics, and chemistry. Also, in terms of mathematics, you can look at maths and further maths, which we call engineering mathematics, okay? Both for beginners and for those in advanced classes. Adia, nice having you here. Thank you, Nana, for that compliment. Thank you, Sophia. I so much appreciate you. It is by our Nigerian time, it's just 9 p.m. So you are 3 hours ahead of us. Thank you, and do have a nice day. Okay, Nana, I'm from Nigeria, West Africa. You're watching my stream live from Nigeria. And by our time, it is some minutes after 9 p.m. So I think you are like 3 hours ahead of us. After this class, I should be thinking of going to bed. You can also follow me on TikTok. I'm also on TikTok, on Facebook, and on YouTube. Sarah, don't forget, I'm still waiting for your solutions. Sarah, can I get solution to question number 16 and 17? Okay, Sarah, for question 16, this is what you will get. Now, irrespective of the number of powers you have, all you need to do is to multiply the powers. Because you know that starting from the bracket inside, you have to simplify it, and this is going to give you exponential a times 6 all raised to power c. Now, when you do this, it's going to give you exponential a 6a all raised to power c, and you simplify this further, it's going to give you exponential 6ac. So at the end, this is what you will get. Ordinarily, you can just express it as from here as exponential a times 6 times c. I have to take it one at a time to enable you to understand it better. Okay? And at the end, you arrive at the same answer. Okay? So, 17, this is going to be, you have to cube 10, 10 cube times y raised to the power of 5 times 3. This is equal to 10 cube y raised to the power of 15. So Sarah, this is what you get. Sarah, are you here with me? Okay. Sarah, I want to believe it's clear to you. Sarah, let me pick a call. I'll call you back. Okay. So Sarah, we are going to take the last law for this particular class, and we call it the zero or negative indices. So let's have it 0 and negative indices. So I'm going to take the last two laws together so that we'll end the class on indices today. Example 1, we are asked to simplify a raised to the power of 4 divided by a raised to the power of 4. Now, using the full expansion method, which I taught you, you will see that if you have to divide a raised to the power of 4 by a raised to the power of 4, this is going to be a raised to the power of 4 can be expressed as a times a times a times a divided by a raised to the power of 4, which is a times a times a times a, right? And when you divide, a will divide a will divide a will divide a, and a will divide a. And at the end, you discover that you have a raised to the power of 0. So a raised to the power of 0 is said to be 1, of which you said this is 1, 1, 1. Okay, when they divide themselves, gives you 1. And this can be said to be equal to 1 times 1 times 1 times 1 is said to be 1 over 1, and 1 over 1 is still equal to 1. Or we can say it is a raised to the power of 0, meaning no a is left. So we refer to this as the power, the 0 law, of which we can say that we can also use this to be, remember what we said concerning the subtraction law of indices, that a raised to the power of 4 divided by a raised to the power of 4 can be said to be equal to a raised to the power of 4 minus 4, where this is division and the bases are equal. We say you subtract the powers, and when you do that, you are going to have a raised to the power of 4 minus 4, which is 0. And since equation 1 and equation 2 are said to be the same, if I call this equation 1 and call this equation 2, and they both give us the same answer, then we can say that a raised to the power of 0 is equal to 1. This is what we refer to as the zero law of indices. And in general, any number apart from 0 itself raised to the power 0 has a value of 1. So be it 10 raised to the power of 0 is equal to 1. Be it 100 to power 0, 100 to power 0 is equal to 1, except 0 to power 0. And I think 0 to power 0 can be said to be undefined. But any other number or letter or alphabet, whatever you want to call it, raised to power 0 is said to be 1. So let's look at the negative power law. But before we go to that, do you understand what I have said? Is it clear to you, Sarah? Okay, all right, so we move to the negative power law. So looking at the negative power law, let's look at example 1. In example 1, we are asked to simplify. A raised to the power of 4 divided by a raised to the power of 7. Now, also, when you use the full expansion method in solving this, we say it is a times a times a times a divided by a times a times a times a times a times a times a. And when you divide this, this cancels this cancels this, this will divide this, and this will divide this. All goes 1 1, okay? And then we have it that 1 times 1 times 1 times 1 is said to be 1, right? And a times a is a squared, a cubed times 1 is a cubed, times 1 times 1 times 1 still gives us a cubed. So this is said to be a raised to the power of 3, that's a cubed, right? So it therefore means that a raised to the power of 4 divided by a raised to the power of 7 gives us 1 divided by a raised to the power of 3. Also, the law of indices says that a raised to the power of 4 divided by a raised to the power of 7, going by the subtraction law of indices, we have it that when it is division, we subtract the powers, and this can be said to be a raised to the power of 4 minus 7, right? Good. And this is equal to 4 minus 7 gives us what? Minus 3. So this is a raised to the power of minus 3. But if I call this equation 2 and take this to be equation 1, you will discover that since equation 1 is equal to equation 2, because we are still dividing a raised to the power of 4 by a raised to the power of 7 and arriving at different answers, it therefore means that a raised to the power of minus 3 is equal to 1 divided by a raised to the power of 3. This is what we refer to as the negative power law of indices. That is to say that a raised to the power of minus 3 is equal to 1 divided by a raised to the power of 3. In general, if we have a raised to the power of minus m, this is said to be equal to 1 divided by a raised to the power of m. This is what we refer to as the negative power law of indices. Or if you have 1 divided by a raised to the power of m, it is also equal to a raised to the power of minus m. Sarah, do you understand that law? Is it clear to you, Sarah? If it is clear, then let's take more examples or exercises on these two laws that I have given you, because I want us to end this class by today. This topic, sorry. So let's look at exercise 1.10. We are asked to simplify the following. Number 1, I'm going to copy out the question, then we'll solve it together. But you can go ahead and start solving. I'm coming out the questions, after which we shall solve them. Number 11. number 15. Okay, so for today, let's look at this. All right, so Sarah, I'm going to be solving this. Do you understand all I have explained now? Okay, so let's go ahead in solving this. I'm going to be solving, and I will solve out of 15 questions. I'm going to solve some and later allow you to solve others, okay? All right, you said you don't understand, not really, but by me solving them, I think you understand better, okay? Just understand what the zero law is all about. The zero law says that any number, any term raised to the power of 0 is 1, excluding 0. But any other number raised to the power 0 is said to be equal to 1. The second law, which I said it is the negative law, says that any number raised to the power of a negative term or a negative power is equal to 1 divided by a raised to that power, and which I gave you there, which is there on the board. This is the negative law. What the negative law is all about, that a raised to the power of negative m is equal to 1 over a raised to the power of m, which I just proved to you, as well as the zero law, which says that a raised to the power of 0 is said to be equal to 1. So we shall use these two laws in simplifying the exercises I just gave. Now, we are asked to simplify the following. 5 raised to the power of negative 3. This is a negative power law, and this can be simplified to be equal to 1 divided by 5 cubed. Shikena, that is all you are expected to do. We are asked to simplify it, leaving it in indices, okay, indices form, okay? But if you are asked to simplify it further, as the question says simplify, then I will have to do it as 1 divided by 5 cubed, means 5 times 5 times 5. And 5 times 5 is what? 25. 25 times 5 is 125. So this can be simplified further to be 1 divided by 125. And if you so wish, you can then use your calculator or break it down to give you the answer in index form. Okay? B, still with the negative power law. We have a lot of them, not just a negative power law, but in number 2, I would advise or recommend that you use the indices law of addition in solving this. In fact, that's just what to do. Indices law of addition says when you are multiplying, you add the powers. So this is equal to p raised to the power of 2 plus 5 plus minus 3. So this is equal to p raised to the power of 2 plus 5 is 7. 7 minus 3 is 4. So this is what you will get. Sarah, do you understand what I have done using these first 2 examples? Do you now understand? Do you understand this, Sarah? Okay, it's actually getting clearer. Okay, now can you give me solution to question number 3? Now what you have to do in question number 3 is to apply the subtraction law of indices, which I taught you. Okay, the law says when you are dividing and the bases are equal, you subtract the powers. Okay, so this is going to be equal to, I'm now solving question number 3. So please follow me and you'll be able to get them. Okay, now I'm going to solve, if need be, all of them. Thereafter, you can then resolve them on your own. I think that will give you a better understanding. So this is equal to, law of division says when you are dividing and the bases are equal, yeah, you subtract the powers. So this is going to be x raised to the power of minus 3 minus 7. Just take it that whenever you have division, you introduce a negative sign. So this is minus times minus, okay? And this is going to be equal to x raised to the power of, simplifying this further, you have minus 3. Minus times minus 7 will now give us plus 7. So that this is equal to x raised to the power of minus 3 plus 7. Using your number line is going to give you positive 4. Are you with me, Sarah? I hope this is getting clearer. While in number 4, we have 3/4 raised to the power of minus 2. This is a negative power law. And the negative power law says this is equal to 1 divided by 3/4 squared. But I want to show you something. Whenever you have a fraction all raised to a negative power, this can be said to be the inverse law. Because if I'm to simplify this further, this gives me, this is equal to 1 divided by 3/4 squared means 3/4 times 3/4. Okay? And this can be simplified to be 1 divided by 3 times 3 is 9 divided by 16. Now, what this means can be simplified to be 1 divided by 9/16. And when you are dividing 1 by 9/16, in simplification, we said when you are changing a division sign to a multiplication sign, you reciprocate the second term or the term after it. So this now becomes 1 times 16/9. So this is equal to 16 divided by 9. And that will give us 1 whole number, 7/9. So immediately you see this, at this point, I can take this to be equal to reciprocate or invert the fraction and remove the negative power, the negative sign, so that this can be said to be 4 divided by 3 all squared. And you can then simplify it to be 16 divided by 9, which is same as this. So it helps you shorten the process. That is what negative power does to a fraction. It reciprocates the fraction. Question number 5. This is said to be y squared times y raised to the power of minus 4 times 2y. Now, what you will do is that the coefficient of y in this case is 1, this is 1, and this is 2. So I will first and foremost multiply out the coefficients. That is to say, 1 times 1 times 2 is equal to 2. Now you may ask me, how come the 1? There is no number there. Just like what some students will tell me, that there is no number. So why are you putting 1? Now, if the coefficient is not there, of an algebra is not there, note that it is said to be 1. So you may either write it or not. Now, I just introduced it so as to make it clearer for you. Okay? So, 1 times 1 times 1 is 2. 1 times 1 times 2 is 2 times y squared times y raised to the power of 4 times y, which is the same thing as y raised to the power of 1. Now, when you simplify this, you then have 2y raised to the power of, this is the indices law of addition, which says you add the powers. So it becomes 2 plus 4 plus 1. And 2 plus 4 is 6. 6 plus 1 is 7. So your answer is said to be 2y raised to the power of 7. Question 6. Sarah, are you with me? Sarah, are you with me on this? Don't worry, after this we are going to end the class. All right. So question 6, we have 1 over 9 all raised to the power of minus 1 over 2. Okay? And remember what I said concerning the negative power law, that if it's a fraction, you invert the fraction, and that eliminates the negative sign. So this can be said to be equal to 9 over 1 all raised to the power of half. You invert it, okay? The same thing as you saying you turn it upside down, okay? The numerator becomes the denominator and the denominator becomes the numerator, okay? So 9 divided by 1 is still the same thing as 9. So this is equal to 9 all raised to the power of half. I doubt if I have spoken to you about the fractional law, but the fractional law in this case talks about, now, why we did x squared, we said it means x multiplying itself 2 times, right? In a fractional law, what this means is square root of 9. If this is 1 over 3, it should have been the cube root of 9. When you have 1 over 4, it becomes the 4th root of 9. So this means square root of 9, which you can write as root 9. And square root of 9 is said to be equal to 3. Nevertheless, in order for me to prove to you that this simply means the square root, I can simplify 9 to be 3 squared all raised to the power of half, right? Good. Now, remember the power law, the multiplication law of indices, that you multiply the powers, so that this now becomes 3 raised to the power of 2 times 1 over 2. This is over 1. So this is equal to half times 2 is 1. So this is 3 raised to the power of 1, which is the same thing as 3. So that shows you that half as a power simply means square root. Alright, so question 7 is equal to, I'll also multiply out the coefficients so that this gives us 3 times 2 into bracket m raised to the power of minus 1 times m raised to the power of 2. So that this is equal to 6m raised to the power of minus 1 plus 2, which is equal to 6m raised to the power of minus 1 plus 2 is 1, which is equal to 6m. And question 8, remember this 4 is going to affect the power. You're going to multiply all the powers of the letters or digits in that bracket, okay? So that this is said to be 2 raised to the power of 4 times a raised to the power of 8. Sarah, I don't want to keep you late, so let's go straight ahead and do this. Negative power, this is equal to 1 divided by the whole thing you have in that bracket, which is 1 divided by 3q squared, because that is what this bracket means. Otherwise, you would have said 1 over 3 times 1 over q squared, which is the same thing as this, okay? So, times q over 1. This q is not a fraction, okay? So, don't be deceived that you put it at the denominator, no. Okay? So that this gives you q divided by 3q squared. And this can be said to be equal to, let me factorize out 1 over 3. This is said to be 1 over 3 times, this is division, q raised to the power of 1 divided by q raised to the power of 2, which is subtraction. Otherwise, I would have said this q will cancel one of this q, right? Okay, let me not even go this way. This q will cancel one of this q, so that at the end, our answer is said to be 1 over 3q. This is your answer. Question 10. Question 10, multiply out the coefficients. This is said to be 2. They all have the same basis, which is y. This is y raised to the power of 1. So this becomes y raised to the power of 1 plus the power of the second term, which is m minus 1, plus the power of the third term, which is 1 minus m. So let's now add up all the powers. This is said to be equal to 2y raised to the power of, let me add up all the numbers first. 1 minus 1 is 0. 0 plus 1 is 1. So we have 1. M minus m is 0. So your answer is 2y raised to the power of 1, which is equal to 2y. What about this? Multiply out the coefficients. 4 times 6 is 24. A raised to the power of 0. But we know that a raised to the power of 0 is 1. So this is best written as 24 times 1. And 24 times 1 is said to be 24. Sarah, did you get that? At the end of the class, you can still go back and rewatch this part of the video. It's still live on YouTube. So this is equal to, I will then simplify number 12. I already know that this is x raised to the power of 0, and x raised to the power of 0 is 1. 13 times 1 is still 13, right? So this can be said to be, for the purpose of show working, this can be said to be 13 times 1 plus, everything in this bracket raised to the power of 0 is 1. So this is plus 1. So simplify what you have here first, and this gives you 13 plus 1, which is equal to 14. Question 13, you have 10a squared times 4d squared e squared. This can be said to be, multiply out the coefficient. This is 40, multiply out the numbers, the letters. This is a squared, d squared, e squared, or divide by, simplify the denominator before dividing. This is 4d raised to power 4. Remember, we have to multiply every digit. That's 4 to power 4. And 4 to power 4 is what? That's 4 times 4 times 4 times 4. 4 times 4 is 16. So this can be said to be 16 times 16. So I will express this as 16 times 16 so that I can simplify it. Then d raised to power 4 as well. So what can divide 40 and 16? I will say 8 can go. 8 into 40 is 5. 8 into 16 is 2. Then we have like terms of d. This is d squared and this is d4. So d squared into itself is 1. D squared into this will go 2 times, or d squared times. So that this, nothing else can divide, because this is 5, this is 16. Please, on no account should you say square will cancel square. No, it is wrong. Okay? Because they are not like terms. So that this now can be said to be simplified to be, at the numerator I have 5, a squared, e squared, divided by denominator 2 times 16 is 32. So this is 32d squared. This is what you will get. And I doubt if anything, if you can simplify this more than this. 14, I'll also simplify the numerator, simplify the denominator, and then if anything is common at numerator and denominator, I can then divide. This is equal to 18 numerator. I have 18 times 4 into bracket. This is, okay, sorry, it's not 18 times 4 because we have cube, and this cube is also affecting 4. Okay, so 4 cube means 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. Okay, so this is 18 times 64 into bracket. You then multiply. This is x, sorry, x to power 8 times x to power 9 divided by the denominator, which is 24, x to power 17. So when you simplify this further, this is going to give us, okay, this is going to give us 18 times 64 into x raised to the power of 17, because 8 plus 9 is 17, divided by 24 x raised to the power of 17. This automatically becomes 0 because x raised to the power of 17 will cancel itself. So what can divide 18 times 64 and 24? I will say 8 can go. Okay, so 8 into itself, 8 into 64 is 8 times. 8 into 24 is 3 times. Without remainder, you look for a factor that can divide both numerator and denominator, and you divide. So 8 is that factor that can divide 64 and 24 without a remainder. Also look at a factor that can divide 3 and any of the terms at the numerator. 3 cannot divide 8, but 3 can divide 18. So 3 into itself is 1. 3 into 18 is 6. So there's nothing else that can divide. So we can then simplify and arrive at our answer, of which 6 times 8 is said to be 48. So this is your answer. And our last question for the day is 15. 15, we have 2c squared all cubed times cd all divided by 8c raised to the power of 7. Simplify what you have here by cubing every term in that bracket. This gives you 2 cubed c raised to the power of 2 times 3 times cd divided by 8c raised to the power of 7. When you simplify this, 2 cubed is said to be 2 times 2 times 2, and 2 times 2 is 4, 4 times 2 is 8. So 2 cubed is said to be 8 times c raised to the power of 6 times c d all over 8c raised to the power of 7. When you simplify this, this is equal to, multiply out the coefficient, this is 8c, c raised to the power of 6 plus 1, that's c raised to the power of 7 d all divided by 8c raised to the power of 7. 8 will cancel out itself. C raised to the power of 7 divided by c raised to the power of 7 is 1. So our answer is said to be D. So these are the solutions to the questions we have on the board. Is it clear to you, Sarah? Do you understand? Sorry for spending almost 2 hours with you into this class. Sarah, is it clear to you? Sarah is not online. Okay, I'll end the class at this point. Thank you for being part of today's class. See you in our next class when we shall be taking a new topic. Do have a nice day.